Hey everybody, it's Mr. Mott. What I want to do is go through the analysis of our green food dye and bleach kinetics lab, getting us introduced to the time-based mode on our LabQuest. So what I've already done, I've got my LabQuest hooked up to the SpectroVis Plus. And then what I did is that I took my stock solution. The stock solution is green food coloring diluted 1 to 10. So I took 1 milliliter of the green food dye, I diluted to 10 milliliters total. That's our stock. I took 1 drop of that and then diluted that with 10 milliliters of water. And then that was my solution that I used to determine the peak wavelength. And as you can tell on our screen here, the peak wavelength that I came up with is around 625, 626 nanometers. And so I did that in the full spectrum mode. So that's the same as what we've done in the past. So if I was to look at that again, I would change my mode, which is currently in time-based, it'd be in full spectrum. So in order to change my mode, and just to kind of double check my settings, I'll press the mode, and where we were in full spectrum. Now we want to go to time-based. So what we want to do is that we want to collect our data. We're going to take our sample that we just got our wavelength, going to pour that back into the original, so that the stuff that's in the cuvette that we used to find the peak wavelength that we were going to collect our data at, our absorbance at, pour that back into our original container, and then you're going to use 2 milliliters of just regular old bleach. You're going to pour the bleach in there, and you're going to let it react. Now, before you mix everything, you want to make sure you're in time-based mode. And then these are probably the default settings of rate of 0.5 samples per second or 2 samples per second. That's usually pretty good. And I would do a duration of at least 200 seconds. I did 300 seconds. But either way, that should be sufficient. So I'm going to hit OK. That's where we were. Now, when you guys do this, when you hit OK, it's going to prompt you to save your save it, and you come up with a file name that you're going to save. And then we're ready to collect our data. So at that point, once you have a screen like this, what you would do then is that you would, again, you'd have poured your sample from that was in your cuvette back into your beaker that you had your sample in. Add 2 milliliters of bleach to it, give it a quick swirl, pour that into a cuvette, and collect your data. Now, I'll show you the data I came up with, and so we can learn how to analyze it. So here's my graph. So I'm going to go back to my graph about what we came up with. So pretty nice little curve here. This is absorbance versus time. And so typically we would be looking at a graph of molarity or concentration versus time. Since we're under 1, we know that the concentration is proportional to absorbance. And so even though we're collecting absorbance, we can really think about this in terms of concentration. So if this was concentration versus time, since we're not seeing a linear relationship, we know that this is not 0 order. So what we would then do is that we'd analyze it and look at what's the natural log of that versus time, and 1 over this value versus time. So on our LabQuest, we can do that by creating what's called calculated columns. So I'm going to go on the top right here to my table, and I'm going to create a new calculated column. And I'm going to select my equation type. First one I'm going to test is this first order by looking at the natural log versus time. And here's our analysis. Man, that looks really linear. And so to me, right away, this is telling me that this is first order, that our calculated column, which you see on the y-axis is now changed, is now, this is very linear, and this is natural log versus time. Just to double check whether or not this is second order, sometimes it's not as clear as we would like, we could create a new calculated column, and then we'd select a different equation, and it's a little bit clunky how they do the x and the a here, but it's going to be a over x. Oops, I clicked the wrong one. It's going to be a over x. And we can see this is an upward trend, but it's not linear. So So that really tells me that our first value of natural log of absorbance versus time is going to be our linear relationship. So I'm going to switch over here to our first calculated column, and we can see it's very linear. In fact, what we can do then is analyze this, do a curve fit of our calculated column. We're going to choose a linear relationship, and we can see our correlation is really, really close to 1. So that tells me that my data points really match the line really well. And then think about what this slope means. If we think about like our integrated rate law, about what our slope tells us, this is going to tell us our rate constant. So very powerful piece of equipment this whole LabQuest is. So that's how you create your calculated columns. You're going to be using that for like your crystal violet lab and some other ones, and it's pretty slick. So hope this video helped. Have a good day. Bye-bye.